Cyberstrak has released another version of its Rhino plugin, version 2.0. Beside the new license mechanism, it comes along with several new and improved commands. Hi folks, I'm Gigi, and in this video we will have a closer look into all what is new in this new version. Please note that the new perpetual license mechanism is explained in separate videos, which you can find linked here in the upper right corner, as well as in the video description. Let's jump into it. One of the new features is the ability to select a mesh as a projection base in the Cyberstrak dockbar. Once you've selected it, it will automatically be activated. You can choose different display settings if you like to. And then you can use this mesh across several commands to either create new geometry or modify existing one. So one of the new tools, create surface from 4 points, also supports this projection base. As you can see here, it's automatically activated because we have one selected and activated in the dockbar. And now we can set 4 points on this mesh. It has an integrated deviation analysis, which allows us to directly tell how far away from the mesh our surface is. And so we can interactively adjust the degree until we've reached a deviation which is acceptable. The sketch curve point by point command also allows to use this new shared projection base across different commands. And if you're doing that, you get here a P indicating that these curves are projected onto the projection base mesh. Same is true for the dynamic curve sketcher. And as before, you can use the Rhino O-snap to snap ends of sketched curves together, and then you can use the new option, keep common sketch end together, to move these corner points directly, not one by one. Then you also have a new option under curves, which is the direction option, which shows you which parameter flow the curves you're currently creating or modifying have. The Modify Curve or Surface Control Points tool also supports this projection base. And here you have a new mode, which is called Selected CVs. If you enter this one here, you can pick, for example, complete row, but also a second row. And then you can, for example, add a few more CVs to the set of selected CVs. And then you can move all of the selected CVs at the same point in time, while the other CVs only move to ensure that the modified surface stays on the projected mesh. You can of course also reset your selection, pick another set of CVs, for example, move them closer to the center line. With manual modeling, of course, the surface will never be really symmetrical to the center line. Therefore, there is now a new tool available called Make Curve or Surface Symmetrical to a Plane. And if you here select our surface and we want to align it to the y=0 plane and hit apply, then we get the information message that the current distance is too far away. Now we can increase the tolerance above the value of the current gap, and if you do so, then our surface will be aligned to the given plane. And we can also choose to get tangency across the plane. We can also show the mirrored side, and in case we want this surface to actually be created, we can activate the Save with OK button. And if we now click OK, we get both surfaces. The deviation analysis has new options now. You have an option Auto Scale, which automatically chooses a value which makes the deviation good to see. On top of that, you have a new option, Check Local Deviation, which allows you to check the deviation at any point you'd like. The transition analysis is now also capable of measuring the transition quality into the interior of another surface. The refit curve command has been completely reworked. It has a new option now where it's taking over the parameterization from a reference curve. When doing so, the span count, the amount of CVs, as well as the parameter flow of the reference curve is taken into account when reapproximating the new curve. Here we achieve a very low deviation, especially compared to the massive reduction in span count and amount of CVs. Just to give you an overview of the size of the curves here, they have a length of roughly 400 millimeters, which makes this deviation really acceptable. Another new option in the curve refit command is the ability to insert sharp knots. So let's say we have a closed curve we want to reapproximate. And this curve to reapproximate has sharp edges. So we can select the curve, and by the way, here the end handles are becoming handy to allow you to spot where the start and the end of the currently approximated curve is. Now we can insert new knots, sharp knots here in the corner of this closed curve. And then you see we get a pretty good deviation compared to the size of this closed curve here, just due to the fact that we've set these sharp knots just at the right places. Another improvement in the refit curve command is the ability to weight the parameter space of the newly approximated curve. So let's say you have surfaces where the curvature is changing too drastically, and we want to improve this. We start the refit curve command, and here we can see how the curvature is accelerating too fast in the end. So when we reapproximate this curve, we can shift the parameterization to weighted, and we can by that control how many CVs are going to be placed in this area, and by that how fast the acceleration of the curvature is. So we still want it to increase. We want this ramp here to show up, but we don't want it to go up too fast, right? So let's take it like around about this. Let's also do the same thing for the lower curve here. So, and just rising, but not too fast. And now we are going to delete the existing curve here, and we are going to rebuild that one using the blend curve command. Right mouse button click. And if we now look at the current result, obviously this is not better. It's actually worse than what we had before, but its curvature continues, and from here we can work our way to a better curvature distribution. So for that we are going to use the ability of matching a curve. We are going to keep our analysis active here. So we are selecting this curve here. We want to curvature, so keep the existing curvature continuity on this side here. At the same point in time, we want to keep the curvature continuity on the other side as well. So far nothing has changed. But now, because we're inside of the command, we can move these CVs here while keeping the curvature continuity and control how fast, let's switch off the analysis here, how fast the acceleration starts here, right? So let's fine-tune this so that this is rather smooth. Let's start it one more time, but this time do the same thing on the lower part here. So again, we want to keep the curvature continuity on the lower part. We want to keep the opposite side curvature continuous. And now we can move these CVs here as well. Until we get like a nice smooth transition of the curvature flow into this curve blend here.
And if we now extrude these curves, have a look to the curvature flow of these new surfaces, then we can see that this is like a much nicer curvature flow around this area here. If you should have any questions, please send an email to support@cyberstrak.com. Thank you for watching.